Random samples and surveys involves us collecting information, gathering it, and making reports that allow us to make estimates about larger groups. I'll explain that a little more now with these terms. So if you think about a population is a group which you want information on. So if I were talking about the Lovett Middle School, I would say that's my population. I want to make an estimate for what is the whole middle school. So a sample is part of the population I want to use to make that estimate. So I would pick, if I were to say my population was the whole middle school, and I wanted to make a prediction based on what they thought, I would take a sample, and if I wanted to cover the whole middle school, I'd probably pick some 6th grade, some 7th, and some 8th grade. A random sample is where each member of the population has an equal chance of being selected, meaning I assign everybody a number, and then I have some program that can randomly generate the numbers. Say I want to select 20 students from the population, it would just randomly pick numbers, and I would see how those relate to that person. So let's try some example here. If I were to say I want to know what the middle school girls thought was their or were their favorite musical artist or artists, okay? Let's say I were going to make a sample. And my sample, well, first off, let's describe what would be my population there. You should tell me the population is the middle school girls. Now, let me ask you this. If I'm going to take a sample and I'm going to ask only 6th grade girls, I'm going to pick 10 of them and ask them what they think their favorite musical artist is. Is that a very good sample? You should say no, because I'm not representing the 7th or 8th grade girls. What about if, and it's not very random, obviously. I picked just 6th grade. A better way to choose my sample would be to possibly grab every 5th girl who walks in the building one morning and ask them to take a survey on it. I'm going to go into a little more detail on that in the next slide. So let's say we wanted to find out if the composting program at Lovett was effective and whether or not students thought it was a good use of the time and that it was being run properly. So let me describe a couple of samples with you, and let me ask you what you think of them. So again, if I want to know what the students think of the composting program at Lovett, okay? If I were to interview every other teenager that I see at, let's say, Willie's this afternoon, would that be a good sample? You should be able to tell me, no, it's not a very good sample, because odds are we'll get many teenagers that coming in that don't even go to Lovett, so that's probably not a good way to start. What about if I were to interview the students in the 7th grade science classes? You should again tell me, no, that's not very good, because that doesn't represent the population. Our population is the Lovett School and what we think of the whole program. So asking just the 7th graders is not probably going to be very effective. What about if I interviewed let's say, every 10th student that is leaving the lunchroom? Now that would probably be a better sample, because one, it's random. I'm just picking the 10th person that walks out. Also, if I do it over the course of the whole from lower school to upper school lunches, I would get all range of ages. So that's probably my best sample available. Now let's do a nerdy math example. So let's say there were 20,000 calculators that were produced by some company that makes calculators. And they did a random sample of 500 of those calculators. So they had 20,000 that they made, and they were going to sample 500 of them. What they're sampling for is to see if they were defective and what their ratio is of defective calculators towards those that they make. So if in that 500 they discovered they had 3 defective, okay? So 3 were defective out of their 500 sample from their 20,000 population. Okay, now can we use those numbers to make estimates as far as the total number of defective calculators in that 20,000 group? You should say yes, and to solve it we would set it up kind of like a proportion. Actually, just like a proportion. We would say that 3 out of 500, that makes sense, right? 3 were defective out of our 500 sample, is the equivalent to how many out of 20,000? Doesn't that look just like something you've done a lot and always would say you really love doing? Yeah, it is. Okay, so we could cross multiply and divide, right? We could say do this, and let's be more mathematical and not put a question mark there. Let's put a C for calculators, okay? Now, I would say that once I've cross multiplied, 3 times 20,000 is 60,000 equals 500 times C, so 500C. Yeah, forgive me for that not fitting properly. Then, of course, you divide by 500, divide by 500, and then you start doing that. You can cross out those zeros. You get 600 divided by 5. Well, 600 divided by 5 is 120. So we could say that 120 out of those 20,000 calculators were defective. And that's just an estimate based on the numbers and the samples that we drew from our population.